Thank you all for joining today. We are talking about AI infrastructure today and orchestrating across it. I'm joined by Lukas, who is the CEO at vCluster. I'm Kris, the CEO at NetBox Labs. So just a couple logistics. We're going to introduce NetBox Labs. I think almost everyone here probably knows NetBox and NetBox Labs, but also introduce vCluster to everybody here. And then dig into a bunch of interesting topics. And as I mentioned earlier, we will definitely have some time for some discussion and Q&A. And so we really encourage folks who are here live, drop questions in the chat. We'll see them, and I'll orchestrate that a little bit with Lukas, and we'll drive some discussion around it. I'm sorry, I thought I had some logistics, but let me just speak to some logistics first, and then we'll dive into content. A couple things to know. This webinar is recorded. We will send it to everyone afterward, along with, I think, the slide deck, and it'll be posted online. So don't worry if you miss something. You'll be able to engage with this afterward. Aside from that, you can't come off mute if you're in the audience. That's reserved for Lukas and I. And so use the chat liberally. And looking forward to a good conversation. Okay, so let me just start by introducing NetBox and NetBox Labs for anyone who doesn't know us. I'll go fast here because that's not why we're here. If you don't know NetBox, you're probably in the minority in this crowd. NetBox is extremely widely used as the system of record for infrastructure in all kinds of organizations. Today, in particular, we are talking about NetBox's use in AI infrastructure deployments. And we'll parse that out just a little bit and dig into it in a little more depth in a few minutes. In case you don't know NetBox Labs, we are the commercial stewards of NetBox. So NetBox, of course, is an open source project. NetBox turns 10 this month, which is a really exciting milestone. 10 years of pretty big impact on the industry. NetBox Labs is not 10 years old. NetBox Labs was founded in 2023 to act as the commercial steward of NetBox. And so most of the work that happens on the NetBox project, the maintenance of it, new features, and kind of this steady drumbeat of releases every 4 months for 10 years is driven by the team here at NetBox Labs. We also deliver commercial products around NetBox through our infrastructure intelligence platform in cloud and in on-prem operating models. And we're lucky to work with some of the most interesting companies in the world in this space, for example, CoreWeave, or JP Morgan Chase, ARM, Cisco, many, many more. And the last thing I just want to mention, if you're not familiar with NetBox Labs, is the basic operating model of the company is what we call a virtuous circle. Our job is to build commercial products that deliver value on top of open source NetBox and use that to sustain and scale investment in the open source software and community around NetBox, and that's going really, really well. So we thank everyone across the community and our customers for your support. The last thing I just want to mention by way of introduction, at NetBox Labs, we primarily focus on 3 big, what I would call end markets: enterprise networks, AI data centers, and OT network footprints, operational technology footprints, often manufacturing, industrial, that kind of thing. And obviously today we're here to talk about AI data centers. The span of work that we are doing with companies in all of these spaces, but particularly in greenfield data center builds these days, ranges from as early as I've got some space and I've got some power and I want to build a data center and serve some tokens, all the way through management of the life cycle of the infrastructure, deployment and ongoing operations of the infrastructure. And NetBox is serving as the data through thread for that infrastructure across this entire life cycle. So that is us in a nutshell. And now I want to hand it to Lukas for a couple of minutes to Lukas, to introduce himself, introduce vCluster, and then we'll dig into some deeper content.
Awesome. Yeah, thank you so much for the introduction and for inviting me to be in this webinar here, Kris. Super exciting. And yeah, we had a chat maybe a month ago or so, and found out we had a bunch of overlapping customers and folks in our respective open source communities. So very, very natural for us to join forces on a webinar to tell folks even more of how we interact and which layer each one of our companies sit in. I'm Lukas, the CEO and one of the co-founders at vCluster Labs. We kicked off the open source vCluster project several years ago. It's quite mature, not quite as old as NetBox is. Kris, congrats on 10 years coming up here. That is an exciting milestone. I remember 2 years ago when we had the 10 years Kubernetes anniversary and a big celebration, kind of looking back over a decade of Kubernetes. I hope you're doing a fun event around the 10-year NetBox anniversary as well.
I'm going to steal a second there, Lukas, and make a plug, actually.
Yeah, go
For
ahead.
anyone who didn't see it last week, NetBox Evolve is our celebration. It's happening in October at the Kennedy Space Center. And so everybody's invited. Cool event. Check it out on our website. So thanks, Lukas.
Oh, that's awesome. When I saw the title, of this webinar starting with "From Space," I was like, "Oh, are we talking space data centers?" I don't think that was the meaning, but now you're telling me about Kennedy Space Center, so maybe there's something coming up in that direction with NetBox.
Could be.
Yeah, very, very fascinating, that space. What do we do at vCluster in the AI infrastructure space? We essentially, effectively sit a layer above what NetBox is doing. We help people once, the data center is built, the servers are racked, the, cables are all wired up, and now you want to boot these servers up. How do you get the operating system on? How do you configure tenancy within that data center? Some, data centers might be single tenant. Some data centers have multiple companies running inside of them. How do you isolate things? And then how do you turn it into an AWS-like experience? And I know some of the neoclouds actually don't like me saying hyperscaler-like or AWS-like experience because they claim and they already know to some extent that they're better than AWS in a lot of ways in their particular domains. And I think we provide a small contribution to that performance that they can actually stack up against an AWS, etc. You see a couple of logos here on the slide of companies that we work with on the commercial side, and obviously there's a lot more users in the vCluster open source project. We also have a very generous free tier. You can use us for up to 32 GPUs, even completely for free. If those are like B300s, you have a pretty significant investment in that hardware. You can completely free run vCluster on top of it. Besides our work, with the neoclouds, sovereign clouds, etc., we're also very involved with, some of the largest companies in the country, including pretty much the biggest bank in the country, one of the biggest insurers in the company in the country, and a lot of folks that you might be familiar, like a Deloitte and Adobe, etc., are commercial customers of ours as well. There's plenty of talks on YouTube if you're searching for it. There's an AWS tech blog that Deloitte recently published about how they use us on top of the public cloud. So we don't just run in private cloud data centers and AI factories and neoclouds. We also run on top of public clouds as kind of a layer on top. And we work very, very closely, particularly with NVIDIA, around running better on top of bare metal and on top of things like the DGX SuperPOD, for example. I think we can jump to the next slide. Just to outline it a little bit, we are pretty battle tested and proven in this space. You saw a bunch of logos on the previous slide. I want to highlight 4 distinct use cases here for everybody to understand. One of our key use cases right now is managed Kubernetes for AI clouds. So that is effectively if an AI cloud wants to build their own EKS. That is one of our key value propositions. Everybody's decent at spinning up, bare metal servers and putting some kind of operating system on there. Some are okay at launching virtual machines, right? Most of them aren't. But providing managed Kubernetes and managed Slurm and agent sandboxes, right? That is a lot more challenging. And we started with managed Kubernetes, and the other 2 that I just mentioned are in the pipeline. One of the exciting things that is the second use case here, distributed inference, is one of the most exciting ones for me, because inference is something where you want to reduce latency and you want to be as close to the person running the query as possible. And in order to be close to the one that prompts against your LLM, you have to be in a lot of different locations. That means you have to fleet management. That means the strength of a system like Kubernetes really shine. And that is something we help some of the largest providers out there, including Nebius with their token factory. Sovereign cloud is a really, really big push for us as well. We work with some of the sovereign cloud providers, particularly in the European Union, but also starting to work with some of the providers in Asia. Very, very exciting trend there where people want to have more control and more governance within the realm of their own countries or jurisdictions, and hence are building compute capacity. But in order to make an offering to those respective markets, they need to feel like an AWS. And that is exactly what we're good at as a company, help these offerings to feel and look and operate like an AWS. And last but not least, Enterprise AI Factory. I would say this is a relatively nascent space, in the sense that, obviously a lot of the GPU capacity has been going to the neo clouds and to really large scale providers in the past couple of years. But increasingly, we're seeing the enterprise, which we work with on a lot of CPU-based workloads so far, now also bring in GPUs into their data centers or build entirely new data centers, sometimes run by a neo cloud that offers this to them as a private cloud offering. Very, very exciting to be part of that stack and bridge the gap between what they're doing with CPUs and traditional infrastructure and the public and private cloud, and now extend that experience to these new data centers that host the GPUs. And then on the next slide, just a quick reference here. Oh, yeah, put a link in there in case we share the PDF later.
I'll make this bigger again. Sorry, Lucas.
There we go. There's a link on this slide as well if you later get the PDF version on this. So much you're clicking, Kris. But this leads to our reference architecture that we have with NVIDIA DGX. You might be familiar with NVIDIA's DGX SuperPOD product, which is effectively a supercomputer in a box that you can buy. Rack scale systems, the new NVLink systems, very, very exciting what they're doing there. And as part of that offering, we have a reference architecture to run vCluster on top of that in order to turn, a couple of racks of a SuperPOD into a multi-tenant system to hand out compute to different internal teams, business units, and to securely isolate them on this compute. Definitely worth a read for anybody who wants to look under the hood of what we're doing with the DGX SuperPOD.
Perfect.
That's pretty much it for the intro.
Yeah, thank you, Lucas, and thanks for the warning on the link. We will send this out with these links for folks if you want them later. And so now I'm going to start to turn the corner toward, a little more depth in these topics that Lucas and I have been introducing. I think, I took a kind of a scan over who's here live in our audience, and I recognize some names. And so I think we have an interesting mix here of folks who are really steeped in, AI infrastructure in one of these flavors that Lucas just introduced, and folks who are coming from, maybe adjacent ecosystems or communities, networking or enterprise IT or something like that. And so I just want to, for that latter group, for a couple minutes, motivate what we are seeing in AI infrastructure in, call it the last 12 or 18 months or so. And there are a lot of headlines out there that you see, but they roughly distill down to everything in these environments is about what I usually call speed to scale and about utilization. The demand for tokens is very, very high, and the constraint to tokens is how quickly can I bring infrastructure online, and how effectively can I drive utilization of that infrastructure to meet that demand, right? And so this is really all about like speed and effectiveness, and to solve for those problems in these environments that are growing, extremely quickly. What we found, and I think where Lucas and I a month or so ago when we were discussing this, realized like we really agree and aligned is that operating at speed in these builds and connecting this infrastructure with end use cases and real workloads requires cohesion across the stack and the data of the infrastructure. And we're going to pull that apart in a few different ways. So I think we already all know this, and I'm not going to dwell on it in too much depth, but like uh, companies are spending a lot of money on AI infrastructure. It amounts to. This headline number is pretty recent. This is finding from McKinsey that's now projecting about $7 trillion of global data center capex by 2030. I think there are some folks on this call who account for non-trivial portions of that, right? Like um, a lot of investment is happening into this kind of infrastructure, and that creates a huge amount of back pressure. Like we've got $1 billion and we want to spend it to serve tokens, and now we need to put that capital to work and deploy it into real working capacity, right? So that's one of the drivers of the speed to scale need. And then another really interesting data point is that as these footprints get deployed, they do not always get utilized at 100%. And we've heard, I think even just in the last few weeks, topically about cases like SpaceX's infrastructure and how they're doing really interesting deals with large labs to drive utilization of these huge footprints that they've built, right? Utilization is a really important factor here. So one of the ways this manifests for the teams that are actually building this infrastructure is that a huge constraint is time to market, right? Every week we've secured capital, we've secured, real estate, we've secured megawatts or gigawatts, whatever it is. Every week between that and this capacity is live and serving real workloads for our customers is deferred revenue and is lost value. So this is what's going on in the space right now. What we have found is that compressing this time to value, compressing the cycle time between, I've got dollars I want to spend and I've got space and I've got power and I've, intend to build a data center and this thing is live and serving traffic is an incredibly hard logistics problem. The machines that are getting built, these data centers and machines are extremely complex and millions of parts that go into these things at real scale. So this is one of the largest project management exercises that has ever existed on Earth. Roughly $7 trillion of spend in building these machines at extreme speed and scale. And it all has to line up. What is happening on that path between we've got dollars and we want to buy GPUs and get them online and serving tokens, and that actually happening is real hard work to design these infrastructures, to drive procurement of these infrastructures, to rack and stack and cable them. Cabling is a huge factor in these environments. Like the connectivity profile of these data centers is honestly kind of insane. And when you're operating in a more traditional way, and that to me means like Visio diagrams and Excel spreadsheets, which is what we've seen for a decade of NetBox in most infrastructures. There's a lot of drag, and the form of that drag comes in a few different ways. One of them is handoffs at every step of the process between sort of siloed data sets and siloed teams, and handoffs are slow, right? I need to translate my Visio plan into an Excel bomb, and I need to receive a bunch of stuff, and I'm getting PDFs of the infrastructure that's arriving on pallets in the loading dock, and I need to somehow reconcile that with my design. And every one of those steps is slow and mistake ridden. And that's the other form of drag that we see in these kinds of builds is incorrectnesses or mistakes get made, and this results in drift from the plan downstream. And drift from the plan means the infrastructure doesn't actually work when you push the power button, right? And so then you end up taking a ton of time to debug and solve for those issues to get these things live. So the answer to this is a data through thread from the outset. And I want to now start to explore what that means on the physical side of this, and then we'll connect it to Lukas in a few minutes on the orchestration side of the house. And I want to introduce, for the first time, I think, in this conversation, this concept of what I usually call the cut line. There are multiple systems that need to interact effectively and share data effectively in order to connect all the dots between I want to buy and build a very physical infrastructure. I want to orchestrate workloads on it effectively at scale. And so we're going to spend a little time around that cut line today. And below that cut line, maybe no surprise, it's NetBox managing the physical footprints. And I'll pull that apart a little bit. And above that cut line sits vCluster orchestrating the workloads on these footprints. So we've introduced this just a little bit already, but I just want to reiterate, like, what actually goes into building these environments, right? I've got, 200 acres, and I've got 150 megawatts, and I have some capital, right? Like, I want to go build a really big data center or an AI factory or whatever it is, right? And for anyone who isn't steeped in this space, again, there's a lot that goes into this. There's the power draw calculations of, like, I'm going to have all of this componentry and I need to somehow connect that with the 150 megawatts that I've gotten commitment on. There's heat. These GPUs are going to throw off an awful lot of heat dissipation. How am I going to solve for that? And these days, that's mostly liquid cooling infrastructure. There's the physical space, like the rooms in which these racks are going to get deployed. How are they going to get laid out? What kind of density can we accommodate? How are we going to cool these footprints? What kind of weight can they accommodate? Because a rack of GB300s is really heavy, actually, it turns out, right? So, very physical stuff that as infrastructure IT teams we don't often think about goes into the designs of these data centers. And then we get up into stuff that starts to feel a little bit more familiar, like the cabling topology. And these network designs, really have to take into account the workload characteristics of what is going to be placed on them. Is this a training cluster? Is it kind of an all-to-all topology where every some number of hours in some large training workload, all of the GPU servers are going to have to exchange like a terabyte of data with respect to each other? Or are we building a mixture of experts model where, like, there's just a lot of data flying between any pair of elements of the infrastructure at any given time? Like, the characteristics of the workload really matter to the design of the footprint, the cable topology that we're deploying. And this also connects all the way back to the physical. Small anecdote for a second. Some time ago, I was meeting with one of our partners, who's one of the largest fiber optic cabling providers in the world. Their number one business problem is returns. And the reason is that all of these companies that are building these gigantic data center footprints often don't have a clean, like, physical design for the cabling footprint in advance of ordering all the cables. And so what do? You order cables of all kinds of different lengths, and then you end up with this gigantic pile of fiber optic cables that you didn't actually need to build this stuff because you're figuring this out on the fly, and then you return it to the company, and they have to figure out how to reintegrate that into their inventory and so on. These are real interesting problems when you're building at this speed and scale. And then finally, up above this, we actually get to, like, GPUs, right? And doing training or inference workloads, and Lukas will talk about that more. So a huge amount of work goes into these infrastructures. One of the things that we see in the teams that are doing this stuff best, and not everybody is doing this best, is you need to build a consistent, what I call through thread of data from the moment you have intent to build one of these machines, one of these AI factories or data centers. And that data through thread is what you ground yourself in all the way through live operation and orchestration of these workloads up above the cut line. So the teams that are doing this really, really well are doing design iteration on the data center in NetBox's data model itself, for example, before they've bought anything, right? They've got capital, they've got space, they've got power, and there's iteration happening often in partnership with their customer. Maybe it's a lab, maybe it's an enterprise or something like that on actually what infrastructure are we going to deploy to meet the workload goals that we have. What can we procure through our supply chains? What meets our power and space and weight and thermal constraints? So that design iteration is happening, and it should be happening in the same system that later on is going to feed the operationalization of those workloads. When you've done that, the next stage of this process is now I got to buy a bunch of stuff. I've got to design. I know which cable lengths I need because I've proven that out in my design. I know, the cooling footprint. I know the switching fabric that I need to purchase and deploy. Out of that design come bombs, right? I need to go now procure a bunch of stuff. I need to receive it. We talked about this earlier into the loading dock. And as it's arriving, I want asset tags on these things, and I need to reconcile those assets with my design so that I know, grounded in that design intent, that I've got the inventory I need to actually effectively realize that design in practice, right? And so this is where having that consistent data through thread really starts to matter. Like my purchasing is driven from the design, my reception of the asset inventory is driven from the design, and as a result, I have confidence that I can actually deploy all of this stuff that's arriving on the loading dock, and it may work, right? The next stage of the process generally is we usually use the term cut sheets, right? Like I now actually need to hand my field technicians a plan for their work to take this stuff off the loading dock, rack it, plug it in, cable it, power it, cool it, turn it on, right? And only now, are we into like provisioning, validating that this gigantic machine is ready for work, and handing it to Lukas so that he can orchestrate workloads on top of it, right? So what we see is that the teams that have a consistent data through thread from design all the way through this process, they get it right. They make fewer mistakes. They compress the time for this whole process. And then the teams that started with like Visio or some CAD tool, and then later on they're translating that into an IPAM plan, for example, generally have a lot of manual reconciliation to do at every step of this process, or translation to do at every step of this process. Mistakes get made. You're going back to earlier phases to try and understand design intent, etc. So we introduced just briefly earlier this idea of a cut line, and I just want to reintroduce it one more time. Through this design to operational cycle, what are we managing in NetBox? The stuff that we've always managed in NetBox: the physical infrastructure, the network configuration. But what NetBox is not really great at, and we're not trying to be great at, is above the cut line, like the more dynamic or ephemeral orchestration of particular workloads on this infrastructure. However, the data that is sitting in NetBox is fundamental to be able to orchestrate above the cut line, is a really important input to Lukas and vCluster so that they know what they have to work with in that orchestration. So that's this notion of a cut line, and Lukas will speak about the orchestration that happens up above. And the last thing I want to mention, I don't think I need to dwell on this because Lukas did a good job of introducing some of these concepts earlier, is like, I just want to draw commonality actually across some of the different flavors of infrastructure that we see. We talk about hyperscalers. Lukas introduced the concept of neocloud footprints and AI factory footprints earlier. And in almost all of these cases, there is physical infrastructure that needs to get deployed really rapidly, and it needs to feed orchestration in different flavors. That may be orchestration serving, multiple internal business units. That might be orchestration serving you and your credit card saying, I want like, 10 GPUs for the next 6 hours or something like that. But one way or another, that orchestration has to happen across this cut line. So with that, I want to hand it to Lukas. Oops, I'm sorry, Lukas, who's going to talk a little more depth about what's happening up above that cut line.
Yeah, we can advance to the next slide. Let's start with the problem, right? So whether you're an enterprise building an AI factory yourself, or whether you're an aspiring neocloud that wants to serve, 20 different customers in the next 12 months, um, your problem is always going to be, how do I drive up utilization of this incredibly expensive hardware that I hopefully I use NetBox and ordered the right cables, verified everything, and things are actually wired up correctly and up and running. The question that I now have is, okay, how do I actually serve my internal customers in my enterprise, or my external customers, if you're more in the case of a neo cloud or a sovereign cloud. And the most trivial approach with, particularly if you're talking about inference, I know obviously in the training world we're more in terms of Slurm, but in inference, predominantly we're seeing Kubernetes as the underpinning for VLLM, Dynamo, and Run AI, and pretty much any kind of frameworks that run on top of it. A very trivial approach, and this might be familiar for some of the enterprises that have been doing this with CPUs before, would be to create one large Kubernetes cluster in the private cloud, and then have all the tenants effectively run on top of this single cluster. That, however, is a big problem, because these tenants are really not isolated incredibly well. You have a shared scheduler, you have a shared control plane, you effectively have the same nodes. You could, enforce some policy layer here, but you're effectively running on the same compute fabric. You're running on the same network fabric, right? Technically, all of these nodes can talk to each other. So there are a lot of issues with this approach in terms of isolation, but there are also a lot of issues in terms of autonomy. If I, for example, want to allow team A to run AI and team B to use Dynamo, right? There's already going to be conflicts in terms of like, okay, how do I divvy out these different schedulers trying to use the hardware? And, unlike CPU workloads, we're dealing with, a lot of this, and you mentioned it earlier, Kris. A lot of these workloads need to run very topology aware, right? So it's not just like, it doesn't really apply anymore that I can say, oh, this can run wherever, right? Like a CPU is a CPU, right? When you spin up an EC2 instance in AWS with CPUs, you don't really care what like generation of AMD CPU or whatever that is, right? You don't generally ask. With GPUs, that matters. It matters a lot, whether this is an A100 or B300, right? The performance is going to be vastly different. And then whether, two GPT-300s are, correctly NV linked and partitioned correctly or not matters a lot as well. So yeah, I think this is one trivial approach that is going to be very, very problematic for most. We can click to the next slide. This other approach is essentially, let's create two completely separate clusters, right? That is obviously the other extreme, right? To say, okay, I have business unit A and business unit B, or customer A and customer B in the case of more of a neo cloud or sovereign cloud. I create completely separate clusters. That is also problematic. Kris, if you advance to the next slide, because effectively you have underutilization in some of these tenants. You have, folks operating at capacity limits in other instances. And if you have new tenants, you might want to, shift over capacity, free up capacity. That is, going to be a little bit of a problem as well. So this is a very, very rigid approach, right? The other one is much more dynamic, but very, very hard to isolate things correctly. This one is very, very rigid and static. and leads typically to heavy underutilization. We've seen deployments that had less than 40% utilization overall, which is a real big problem if you just spend $1 billion on NVIDIA hardware. So you want to fix this and get ahead of this as soon as possible. If we go to the next slide, we'll see the difference between static provisioning and dynamic provisioning, which is what we do. So in the case of, for example, the DGX SuperPOD, this is one of the graphics here from our reference architecture for the SuperPOD. They have a system called BCM, which effectively is a node provisioning system. We are not tied to BCM. We can work, on top of Metal Cubed, on top of Ironic, on top of a regular OpenStack. We can provision vSphere VM if you want to do that. And we can tie into things like canonical mass, pretty much any of these systems. We do have a direct integration into BCM, and we are going to announce a direct integration into Nico, which is NVIDIA Infrastructure Controller, which is a newer flavor of what NVIDIA does now in the open source regarding, PXE booting servers and configuring NVLinks and operating DPUs. There's a lot of exciting network technology on the software that NVIDIA does there, particularly with regards to the DPUs. In the static case, you would typically operate these systems yourself, right? You would use OpenStack, BCM, mass in order to create these machines, assign them statically into Kubernetes control planes, and then hand those out to folks, or you would even provision end user platforms on top of that and hand these out to your tenants. We can do this more dynamically. The way this works is with a technology called Carpenter that we effectively incorporated. So it's a great open source project. AWS launched this a couple of years ago. It is actually the underpinning of AWS's EKS auto mode, which effectively is, one of the biggest problems AWS has with EKS is nobody knows like which node types. Like there's like 1,000 different EC2 instances you can create. Which one is the right one to optimize my workloads? That was essentially the problem that AWS wanted to launch. I'm super grateful that they ended up deciding to launch to solve this problem in the open source. So they created this project called Carpenter, and they implemented a Carpenter provider for EC2 because obviously they want to solve this problem for EKS, and EKS uses EC2 nodes. The question you have in your private data center on bare metal though is there's no EC2 API you can use for that, right? So how do we, there's so many different provisioning systems, right? So what we did in vCluster, we baked in open source Carpenter, and we built a general purpose provisioning system that has drivers to tie into each one of these systems, including BCM. We also have a Terraform and OpenTofu integration. So whatever you can provision with Terraform and OpenTofu, you can connect to us as well. So for example, we don't have a dedicated driver for vSphere, but if you want to join in, let's say you need your DGX GPU nodes plus a couple of VMs from vSphere, you can provision them via Terraform and OpenTofu and tie them into the same, VPC via a couple of Terraform runs. That's very exciting. So effectively, vCluster platform, that is kind of our central piece. What it does, it listens to so-called node claims. And each one of these vClusters, which are effectively your Kubernetes control planes now, they produce these node claims. These node claims can be created in a static way where, a platform admin says, I'm going to shift manually workload, or I'm going to request additional capacity for tenant A, or they can be created dynamically, which is even more sophisticated, where we effectively literally see what gets created in these clusters, so which workloads get kicked off, and which ones are schedulable, which ones are unschedulable, and which one of your nodes has which utilization, and where would it make sense to actually remove or add capacity to the cluster. That way, these node claims get created dynamically. You can also have a mix of these. You can say, I want to provision 3 static VMs, plus the GPU nodes at least have 2 of them, and go up to 15, provision them dynamically, right? What we would then do is we would talk to these node provisioners, and effectively these node providers will create the nodes, boot them up, PXE boot them. You have an ISO on their operating system, boots up. You put them in the right network. So we talk to your network automation tool. There's a couple of open endpoints. We see ourselves as a very pluggable system, you can probably tell. So it doesn't really matter to us what kind of switch configuration software you have. We provide, endpoints for you to integrate with. We have a couple of them out of the box baked in. And then we have hard network isolation for these tenants, but still a very dynamic system to move, node A over from tenant A to B. And that is what we mean with dynamic provisioning over static provisioning. We can move to the next slide to explain a little bit of how a stack looks like. So you have the bare metal in your data center. The first question is, how do I, fire up these machines? And again, you can use OpenStack Ironic or Mass. If you don't have anything, we have a technology called vMetal. vMetal is based on the open source MetalCubed project. You can imagine it kind of like the enterprise grade version of MetalCubed. And it is also the one that has all of these different integrations into the other systems, right? So MetalCubed can talk to the other systems or can provision things itself, right? And it adds certain things that a MetalCubed open source project doesn't have, for example, ISO management, where you can allow tenants to create their own ISOs. You can create default ISOs. Obviously, you can lock it down and only allow specific ones, where you can easily patch things across the fleet. That is all the things that vMetal solves for you across different provisioning systems or with the built-in provisioning system. Another thing that it also does for you, it integrates KubeVirt, which is another open source project to fire up virtual machines on these nodes. We do have a configuration for really optimizing this for different types of GPUs. But obviously you can also use it on CPU nodes. I know a lot of folks want to run directly on the bare metal, and that is what we see predominantly right now in the market as well. CoreWeave, for example, is very known for being a bare metal GPU cloud. There's others like Nebius that heavily bet on VMs, right? Effectively, we're supporting both variants of this and even combinations of things. The layer above is orchestration, so we can now boot up bare metal machines and we can boot up VMs. We can have SSH keys and connect to these machines, right? We can manage ISOs, right? Like all of this typical cloud provider operating system. It gets you to basically EC2, right? So you fire up vMetal in your data center and the vCluster platform will lifecycle management and install it for you. So you get to now AWS EC2 parity. The next thing is, how do you get EKS? That is what vCluster solves. vCluster comes in two flavors. It can run directly on machines. That's what we call vCluster standalone, or it can run on top of another cluster. And that is effectively the OG vCluster, how we started the open source project, because we originally started in the public cloud, actually, on top of EKS, on top of GKE, on top of all of these managed Kubernetes offerings. And that is still possible. You can create a vCluster standalone for 5 business units. So you have 5 separate, completely isolated vCluster standalone instances. And now if these business units internally need to sub-segregate things, they can still create the traditional vCluster on top, effectively to divvy things up a little bit better, but with soft isolation rather than hard isolation. Then we have vNode on top, which is effectively a secure runtime for optimized for bare metal workloads and for GPUs. And then last but not least, we recently made an announcement called vCluster Certified Stacks, which effectively helps you spin up additional workloads on top of Kubernetes. So for example, like a Run AI, Array Cluster, Slinky, for those of you who want a Slurm experience and want to do some training, fine-tuning, etc. There's a lot of different tools, and we effectively help you spin them up in a smarter way in lifecycle management, these tools, rather than having to do this yourself. We can advance to the next slide. So if you have this in place, it effectively looks like this. At the bottom, we have, a base Kubernetes cluster, which at the very right-hand side in the black bar, you can see vCluster standalone, right? So this can be vCluster standalone, or it can be any other Kubernetes cluster. It could be Rancher, could be OpenShift, whatever you already have in place. If something's already there, we're happy to run on top of that. Then vCluster platform, that is a central coordination piece. And then you have for each one of your tenants, right? That could be a data science team, an R&D team, an LOB, right? You could have a shared dev cluster. And then these GPU nodes get attached to these respective clusters. And auto nodes is the thing that manages the capacity across these teams with the constraints that you as a platform admin configure. And then on the next slide, I had something really exciting here because this isn't just tied to a single data center. This can actually run across data centers. So you could, vCluster platform, some of our customers run that in AWS on top of EKS, but then they manage capacity in their DGX SuperPOD in the private cloud. And we have a reconciliation system. So even if that arrow there that points to the different providers would break off, right? Things keep on running pretty autonomously in that respective data center or within a Nebius or a Corvex NeoCloud or in a public cloud. And that way you can make use of different chips, your private and your public cloud, and you get a very consistent experience all across the board while getting the best benefits from each one of these providers. There's, for example, a recent funding announcement by a major AMD NeoCloud that just went out a couple of days ago. If you want to use them and you already have a DGX SuperPOD and you're already using, NVIDIA GPUs in AWS, how do you kind of create that consistent experience across everything and manage capacity for your different teams? Because the platform is a great way to do this with. And we can go to the next slide. What allows us to do this is actually what we call vCluster VPN. It's a very exciting technology. It's built on the open source Tailscale project. So we're effectively baking Tailscale in to create a secure VPN across all of these different systems. That means any node-to-node communication, as well as any control plane to node, as well as vCluster platform to the respective control planes of these individual tenant clusters, is all secured in effectively a VPN. And that means even across the wire communication is secure, just like your corporate VPN would be if you're using the Tailscale desktop application and their commercial offering. However, this is entirely based on the open source, so no Tailscale subscription required for this. Is entirely baked on the open source. And our product, as well as the Tailscale VPN coordination servers and derps and everything, is managed entirely on-prem or self-hosted. There's no connection to us, Tailscale, or anything else necessary in order to run our product. And then on the next slide, I wanted to mention we have a direct Argo CD integration. A lot of people do GitOps. They want to spin up, application workloads and platforms. I showed that earlier with certified stacks. That works as code. You can see here the code snippet on the right-hand side. We have a file called vCluster YAML, which effectively is ties back to a Kubernetes resource. So everything you do in our product, the entire UI and everything, every click you do is a kubectl command. kubectl create, kubectl get, kubectl apply, right? Kubectl delete. And, everything can be programmatically orchestrated with YAML, with custom controllers, or with things like Terraform on top, if you wish to do so. And I did put a screenshot in on the next slide here for how our UI looks like. I don't think we have to watch the demo right now. It's might be a little too long for this webinar, but if you can head to vcluster.com/dgx-demo, that takes you to the YouTube page that shows you a quick demo of how do we spin up capacity in vCluster against an NVIDIA DGX SuperPOD running BCM, and how do we ultimately hand out run AI clusters with flexible capacity. And we really show how the nodes join into a tenant cluster and join out and move to a different tenant cluster in this demo. It's a demo I did with NVIDIA together at the last GTC in San Jose. There's the talk is online as well on the NVIDIA streaming website for GTC if you want to get more details beyond the demo. Very, very exciting. That's really the reference architecture brought to life ultimately in the product. And I think that is pretty much all the slides I had for today.
Oops, I of course clicked the video, but we are not going to watch that today. So yeah, thanks, Lukas. Let me make this big again. And so a lot of depth, excuse me, folks, a lot of depth here. We are now at the point in our webinar where we're just going to stop talking at you a little bit and have a little bit of discussion. And there's a few things that I have queued up, from what Lukas talked through or some of our general discussion so far to touch on. But I would just encourage folks who are here, if you have things that are on your mind. Having heard Lukas and myself talk through this, whatever the questions are, drop them in the chat and I can curate that a little bit. And if not, I will roll with it. So, one of the questions that came up right at the very beginning of the webinar, Lukas, was a question from Petrus about open source contribution. And I think one of the things that both of our companies share is, we are open source at the core, right? So, I want to share a few thoughts on Petrus's question, and maybe you can as well. Just speak to how open source fits in for vCluster and how you think about contribution in the community, that kind of thing, right? So, and roughly this is Petrus's question. Petrus has ideas, right? Like he has problems he wants to solve. He would like to submit pull requests. In his case, he mentioned to the NetBox community, and I'm sure there are folks here who, will find for NetBox or vCluster bugs or have feature requests or whatever it is and want to, contribute those things. And so I'll just share general advice here. We are the maintainers of the NetBox community and NetBox open source project, and we engage with every single issue and pull request that comes through the project. Now, the one caveat I want to give to this is the use cases for NetBox, and as we just heard from Lukas for vCluster, like they're vast, right? Like there are a lot of constituencies, there are a lot of stakeholders, and one of the really interesting trade-offs that we have to make in order to serve these like vast set of use cases is not everybody's great idea fits the generality of the project. And so, Petrus, I haven't looked at your issue that you linked yet, for example, but that's the flip side of it is we do not accept every contribution just because there is a contribution. That's how you end up with a spaghetti mess of a project. And so we're very disciplined in how we think about the strategy and the direction of the project, but want to have robust discussion in the community about what really belongs. Maybe Lukas, if you have any thoughts on kind of the open source theme.
Yeah, similar take. I mean, we don't necessarily want to create this, Frankenstein piece of software where everybody can bolt their bits on. But I do think one of the biggest strengths of open source, and that is why, I love open source so much and why we started as an open source project, is the collaborative ideation around things. When I started out, like I'm pretty sure you've been through that same journey, and you start talking to investors, right? And they ask like, oh, is this like free developers, right, in the community? And like, not really, right? Because most of the projects, you find that there's very, very few companies making actual significant contributions. Yes, there's a lot of like small couple of lines, and we're really grateful for anybody who fixes a typo in the docs even, right? Like all of that is super valuable, right? But what I actually appreciate the most about open source is when people understand at a much deeper level what you're doing at the core, right? They can generate better ideas. They can come with a much more, informed opinion. And I think that collective ideation is really the lifeblood of open source. And we as maintainers are in somewhat of the fortunate but also unfortunate situation that we do have to have a filter, and we do have to discuss a lot of potentially competing ideas and prioritize and be a steward ultimately for all of these different voices that we're hearing. And that sometimes can be a little challenging, admittedly.
Yeah, it certainly is challenging. Especially as with these two projects, I think when there's so much adoption and so many great use cases out there. I think we have time, Lukas, for maybe one more question. And I want to hearken to something you and I just recently were talking about, which is observability. And the reason I want to touch on observability is like these clusters are operating, at massive scale, serving real workloads, and things break. I think observability is a really interesting through thread here to explore, like what actually happens across this cut line, as it were, if you're operating some large AI factory footprint or neocloud footprint, and something blows up. And so I know you've been thinking about this recently. Maybe you can comment on that theme a little bit, and I'll chime in too.
Absolutely. I mean, there's a lot of things we can do in terms of shifting workloads around, right? Specifically, if we have very dynamic provisioning in place, as I mentioned earlier. So if certain things fail, there can be failover strategies, and that relies on having the right kind of observability in place to detect the failure in the first place. Um, they are, however, and I think that's, where you're coming in with NetBox and with the physical layer, there are going to be failures where we can't help you with, where we need like hands on keyboard or hands on rack, literally, right, to kind of get things resolved. We had you know, with one of our neoclouds recently, one of the data centers had a power outage, right? And there's not much we can do about that power outage other than hopefully there's some backup power, right? But in that case, a couple of disks afterwards were faulty and they literally had to be swapped out. And what we can do and mitigate in the meantime is reroute traffic, right? Rebalance nodes, right? Like all of these things we can do. But in the end, there needs to be our alerting system needs to tie into you know the operators kind of pager duty or whatever they're using in order to say, hey, somebody needs to go to this particular rack and fix something. And then it comes to inventory management, which is, part of, I think, the value proposition here of NetBox to actually know what is running where is the spare part, and afterwards, understanding the new state because like the current state has just changed, right? Like it's literally drift from the original plan. And that happens with particular GPUs, happens all the time. And these data centers, they're very high throughput. Just the network volume, the volume in terms of storage and data that gets pushed around, it's all at a much, much higher scale. The power that's involved, it's much more complicated than anything we've seen in prior generations of data centers.
Yeah, it's really interesting. I'll just drop one small thought here. I think you explore this really well. And when it comes to actually fixing these problems, ultimately, the outcome we're aiming for is that the workload is being served effectively on an ongoing basis. And when that's not happening, kind of understanding the why all the way down to, in your example, like the disks or the power failure or whatever it is, and understanding what is the underlying substrate that is serving those workloads that are not behaving the way we expect, so that we can go fix that problem. That requires, again, like across this cut line, data to be shared, enrichment to happen, and feed like a cohesive observability strategy. So I think this is a really interesting, line that we ended up exploring together.
And
With
folks might
this, oh,
notice
good.
that there's no observability box in the orange dotted
Yeah,
line at the top. I think I took teased it to you already, Kris.
yeah.
But if you advance I added it at the very end of the deck as
Oh,
well.
there it is. Yeah.
Um, we are actually shipping exactly this kind of observability stack in the product. We have a pretty big announcement in July coming up. And it's very, very flexible. You can see here the different edge collectors. We don't want to be prescriptive and say this is the Prometheus or Victoria metrics or whatever it is, right? You see at the bottom Victoria metrics. That is a example. Effectively, what we're building in our layer is just a write gateway and a querying proxy. And whatever the backend is you're using is very, very flexible in what system it ties into, whatever alerting system you have, whatever data store you're going to use, whether it's Prometheus or Victoria, should be very flexible. And how you're exposing it should be flexible too. But we want to be kind of the gateway in our product. And that's very much how we see the value there. And I did include one more screenshot to give people a little bit of a teaser of what that could look like. This is a screenshot of our UI, and my engineers just gave me this yesterday, so this is like very, very bare bones still, but it's effectively an embedded Grafana dashboard that can obviously be pulled up outside of our product as well, and can trigger into alerting systems. And yeah, Kris, we should probably stick our heads together and see, maybe there's ways for us to enrich that data with the information we could query from NetBox, because as I said, we see ourselves as kind of a querying layer in the product. Whether you have our Grafana dashboards out of the box in front of it, or you have, external dashboards in front of it. And I'm pretty sure a ton of our users are going to have NetBox already in place. And if we tell you, hey, this disk failed, and it is in this rack, in this aisle, right? Like, I think there's going to be pretty valuable information we could generate by combining the two data sources here.
Yeah, for those who are still here, maybe you're a little lucky to get kind of an early look at what vCluster and Lukas and team are building here, but also I'll just chime in, like that's exactly how we at NetBox Labs are thinking about observability too, is how do we couple the context in NetBox with the workload observability of what Lukas and team have built here, or other kinds of workloads, obviously, and enable that sort of rapid contextualization, enrichment of that telemetry, and then obviously downstream of that, remediation of issues and so on. So lots to come there. And with that, we are a little bit over, and thanks to those who stuck it out. And Lukas, thank you for joining me. This is a really fun webinar. Really enjoyed the conversation and a ton of depth here. So hope folks who are here learned a little bit. I suppose I would leave you all with, maybe just like a brief call to action. I think here, I'll go back to this slide. There's a good URL to go check out. Go watch the demo and get a deeper sense of vCluster, especially if you are building these kinds of clusters or just thinking about this, especially if you're in the enterprise and you sort of see GPU or AI factory infrastructure coming down the pike for you. It's important to just wrap your head around all of the problems to be solved in this space and how the networks and the infrastructure you're building have to interplay with the workloads and the orchestration that Lukas talked about. Thank you again, Lukas. We'll end it here.
Thank you.
Care, everyone. I think. Bye.